Welcome to this explainer. Today we're taking on a massive task, but don't worry, we're going to explain the whole topic easily. We are completely demystifying how the human body works. We're going on a journey, starting right down at the micro level with tiny cells and scaling all the way up to complex diseases. It's all about helping you truly understand the absolute marvel of a biological machine that you're operating right now. Here's our roadmap for today. We'll start with the building blocks of life, look at how enzymes act as perfect keys, explore the cardiovascular engine room, see how we fix a broken heart, and finally, understand tumors and cancer. Let's get right into it. Section 1, the building blocks of life. We really have to start at the ground floor to grasp how your body builds itself up from scratch into a working machine. So think of your body like building a house. It all starts with the cell. That's the absolute smallest working unit, literally like a single brick. Now, you group those bricks together and you get a tissue. Group those tissues together and boom, you've built an organ, like your stomach or your heart. Connect those organs and you have an organ system. And when you put all those systems together, well, you've got a whole living organism. You. It's like a giant, perfectly organized puzzle. Moving on to Section 2, enzymes, the perfect fit. Now that we've seen the scaffolding, let's meet the tiny, tireless workers actually making life happen inside those cells. You see, to make all those cells function, we rely entirely on enzymes. These little guys are highly specific biological catalysts. That means they speed up chemical reactions in the body without actually getting used up themselves. It's pretty amazing. The absolute easiest way to picture this is the lock and key theory. Just like your house key is totally useless for starting your car, an enzyme has a very rigid, specific shape, what we call an active site, that only fits one exact type of molecule. A perfect fit. Let's actually look at how this plays out in real time. First, the substrate molecule finds its specific enzyme. Second, it docks perfectly right into that active site, forming a tight enzyme-substrate complex. Third, bam, the chemical reaction happens right there in that little pocket in a fraction of a second. And finally, a brand new product is released. The crazy part? The enzyme is left completely unchanged, just sitting there ready to grab the very next molecule and do the whole shebang all over again. Section 3, the cardiovascular engine room. Zooming out from that tiny microscopic world, we arrive at the ultimate macroscopic organ system. Think of this system as the body's main plumbing and transport network. It consists of your heart and a massive web of blood vessels. This continuous circulatory system pumps tirelessly 24/7 to deliver vital oxygen and nutrients to every single one of those cells we just talked about. And at the exact same time, it's carrying away all the waste products. I mean, your heart beats around 100,000 times a single day. It is the absolute unquestionable core of our biological engine. Section 4, fixing a broken heart. Because, well, what happens when our body's engine room actually starts to fail? Let's talk about cardiovascular disease. When this incredible engine breaks down, it's usually a plumbing issue. Take coronary heart disease, for example. Over time, fatty deposits can build up and actually physically narrow your coronary arteries. It is exactly like a blocked pipe in your house. It chokes off the blood flow, which starves the heart muscle of the oxygen it desperately needs. And as you can imagine, that immense strain can eventually lead to a heart attack. So how do we fix a blocked pipe like that? Well, medical science basically gives us two main options: mechanics or chemistry. Mechanically, surgeons can go in and insert a stent. This is a tiny, expandable wire mesh tube used to physically prop the artery open. It's a very quick surgery, which is great, but it does carry a risk of blood clots or thrombosis. On the flip side, chemically, we can use statins. These are daily medications that alter your cholesterol, specifically lowering the bad LDL cholesterol that causes the buildup in the first place. You completely avoid surgery, sure, but it's a long-term commitment that does risk some side effects. But, hey, coronary arteries aren't the only things that break down in there. We also have to ask, what happens if the heart valves become stiff or leaky? These are the delicate little doors that keep our blood flowing in only one direction. When those valves fail, surgeons have to go in and replace them, and the options here are pretty wild. They can use biological valves, which might come from human donors, or incredibly, even from pigs or cows. No way, right? Or they can use sleek, mechanical, man-made valves. Now, both of these options are absolute feats of modern engineering, but we have to keep in mind they both require major surgery, and they both carry an ongoing risk of blood clots that the patient has to manage for the rest of their life. Section 5, understanding tumors and cancer. For our final section, we are zooming all the way back out to the whole organism to examine a systemic issue. People actually confuse tumors and cancer all the time, but there is an absolutely vital distinction here. A benign tumor is a mass of abnormal cells growing out of control, but, and this is key, it stays locked safely inside a membrane. It stays put in one place, so it is not classed as cancer. Malignant tumors, on the other hand, they are aggressive. They break right through that membrane, they invade healthy tissues, and they hitch a ride in the bloodstream to start new secondary tumors elsewhere in the body. That destructive ability to spread is exactly why only malignant tumors are classified as cancer. Now, when we look at the known risk factors for this kind of cellular damage, it gets a bit personal. While some things are inherited genetics, like the BRCA genes linked to breast and ovarian cancer, so many other factors are tied directly to our daily lifestyle choices. Think about it. Smoking is linked to lung, mouth, stomach, and cervical cancer. Ultraviolet light from the sun or tanning beds drive skin cancer. Heavy alcohol consumption is tied to liver cancer, and obesity increases the risk of bowel, liver, and kidney cancer. It really makes you stop and think about your habits. But here's the thing. Scientists don't just look at these lifestyle habits, see a pattern, and make a guess. No, they have to definitively prove it by finding the causal mechanism. Think of it like a detective finding the actual murder weapon, not just a motive. A causal mechanism is the biological explanation of exactly how one factor definitively influences another. It proves that the chemicals in a cigarette, for example, physically cause the cellular damage that triggers the disease. It takes it from a mere correlation to definitive biological proof. All of this leaves us with a pretty profound thought to wrap up our explainer today. Understanding our biology isn't just theory for passing a science test. It is literally the instruction manual for your own body. It shows us how our everyday habits actively maintain or slowly damage this incredible biological machine. Given how systematically and delicately our bodies are organized, what daily choices will you make today to protect your engine? Thanks so much for joining me, and I'll catch you next time.